So for my Pencast for the homework 3, I chose to do problem number 3. And problem number 3 says to get to graders, you have to go 440 meters west on Ice Street and 920 meters south on Cream Street. Suppose it takes you 42 seconds to complete the 440 meter leg of the trip and 74 seconds to complete the 920 meter leg. So to start out, what I'm going to do is I'm just going to draw out the path that I take. So it says that I go south 920 meters, and that I go west 440 meters. Problem A says, what is the magnitude of your average velocity during this 116-second period? So in order to do that, what we have to do is find the length of the vector. Now the vector would be an arrow just going from where the trip ends to where it started. So that would be the magnitude of the vector. Now, this 440 meters is equal to AX. The 920 meters is equal to AY. Now, in order to find the magnitude of the vector, what we have to do is set up the equation like the Pythagorean theorem. So it would be AX squared plus AY squared, then we take the square root of it. So we set it up like this, 440 meters squared plus 920 meters squared, and have the square root over all of that. And once we calculate that out, it comes out to 1,019 meters. So A is equal to 1,019 meters. Now the problem is asking us what is the magnitude of the average velocity during the 116-second period. So in order to find the average velocity, what we have to do is to take the displacement, or the magnitude of the vector, and divide it by the time. So V average is equal to the displacement, which is 119 meters, over the time, which is 116 seconds. And that comes out to 8.8 meters per second. So that's part A. Part B is asking, what is the direction of your average velocity during the 116-second period of time? Now, in order to do that, it's a simple equation, which is theta is equal to the inverse tangent of AY over AX. So, with that simple setup, all we have to do is plug in the numbers. Theta is equal to the inverse tangent of 920 meters over 440 meters. And that comes out to 64 degrees. So that is the direction of the average velocity. The direction of the average velocity is 64 degrees from the x-axis. So 64 degrees is the angle. Now part B says, what is the average speed during the trip? Now average speed is different from average velocity. Average speed is the total distance traveled divided by the time. So the total distance traveled would be the south leg of the trip and the west leg of the trip. So that'd be 920 meters plus 440 meters. And then in order to get the speed, we have to divide that by the time, which is 116 seconds. This gives us an average speed of 12 meters per second. That 12 meters per second is after rounding, of course. And that is all of problem 3.